Welcome to Advanced VLSI Concepts. Today we are going to discuss how to check timing in Innovus tool. So, like in any design, there will be four type of timing path will be there. One is into reg to out, and into out. So these are the four different type of timing path in our design. These are the also group of timing path which are exist in our design. So we are how like we are considering these path group and how we are extracting the data of these timing groups from a report. So we will go one by one and get the details more about each and every timing path in our design. So as you can also see in this design, we have all four types of timing path. We are facing timing issues in three types of timing path, and we don't have any issue in into out. So first, most violated path is reg-to-reg path. So we are first check with check reg-to-reg timing path. We have to give the command report timing hyphen from all register to all register. This is the command to check reg-to-reg timing path. So it will give the detailed report reg-to-reg timing path. So as you can see in this timing report, we have the start point, end point, and in this report we are facing violation like our slack is violating like minus 6.94. So uh, what exactly is the rest to rest timing path is we have one register and some combo in between this, and in the second register like we have a launch register and capture register in between that some combo will be there. So as you can also see in this report, we have some flip flop where our data is get launched, and in between them some these buffers and other logic cells combo cells are placed, and then again one register like we have a launch path and capture block in between there, that is the combo delays which are contributing to this path delay. So uh, we have to analyze these combo based on like which kinds of cells are placed on the basis of their delays, because our slack get violated like when we are calculating the setup, which is uh, rt min minus at max. So it's calculated on that, and we are getting some slack value in this particular path.
Phase shift in STA is the time difference between the launch clock edge and the capture clock edge when two related clocks do not start their rising edges at the same instant, even if they have the same frequency, same period. The tool shows phase shift is equal to 4.000 ns. This means the capture clock edge endpoint clock occurs 4.000 ns after the launch clock edge start point clock. Why your report shows 4 ns phase shift? Launch from prog0 IU0 day underscore reg underscore CWP underscore 1 DFF. Capture at prog0 IU0 x underscore reg underscore rupees to data underscore 17 DFF. Both are under the same main clock domain, my underscore CLK. But STA has selected two edges that are 4.000 ns apart, meaning launch happens at 0 ns. Capture is expected at 4.000 ns, the next shifted edge. This 4 ns gap is reported as phase shift. Clock period 4, phase shift. That means phase shift is 4. Setup time is also calculated over the library setup time base on PVT corners that we have loaded slow.lib, fast.lib. Setup is calculated for max PVT corners. In this case, it has chooses slow.lib for this register based on lookup table. Now, required time is 4 minus setup time plus some other end arrival time, because clock delayed because of these other end arrival time. Now, 4 plus 1.007, it will be 5.007. So 5.007 minus 0.209, library setup time 4.798, which is our required time, because required time is equal to clock period minus setup time. In this group of path, are slack having violation.
Let's come into next timing group, that is all Well, in this case, all input to all register, like input to register, we are now checking. In this case, we also have this start point and end point, and in this case, we also like getting the most violating path. So as you can see here, some slack values like we are also facing slack in this case. So now we are going to check another timing group, all register to output path, rest to out path. Now we are going to check. So it will also again show the most violating path. In this case, like our uh, slack is met. We have a start point and end point, and end point means it will as a port, output port. So now let's we have checked all these kind of time part, and we don't have any violation in into out path. So uh, now let's discuss delay specific path. Max path based timing searching in our from our report. So we have to give the command report timing hyphen from all register to all output. We are like searching from all register to output path, and we are giving the hyphen max path as a switch, and we are searching max path to 37 as a max path. So it will give the that all the paths violating reports in our design. As you can see, uh, path like all the paths are mentioned in this report. So in this way you have to search and analyze the time path. Now you can also dump these uh, max paths which is 237 are most violated in a report rest to rest dot report. So it will be dumped, and you can search by gedit command and rest to rest dot same name report, and you can see all the timing paths are dumped in this particular report. You can analyze based on these violations.